Well, thank you very much, Nigel, for the invitation to come and speak to the folks here. I always find it a little bit difficult to pitch this to the right level for the audience. So if you do want to interact at any point, ask me questions, points of clarification, please do, because I think that will help me to make sure that I explain things at the right level. So first off, before I start the presentation proper, I just wanted to introduce OpenReach for you, just so that you get a sense as to what it is that OpenReach is about, which is a BT Group business, but it's got a specialised and constrained role within BT Group. OpenReach was formed in 2006 following something called the Telecommunications Strategic Review. In 2005, the Telecommunications Strategic Review was considering whether BT ought to structurally separate its access network assets from the rest of the group. In the end, that was not done, and OpenReach was created as a functionally separate business with its own headquarters, with the mandate to deliver services based upon the access network on an equivalence of input basis. Now, what equivalence of input basis means is that the services that we deliver to downstream BT, to BT Retail, BT Wholesale, have to be the same as the services delivered to other players in the industry, delivered at the same points of service interconnect, delivered under the same commercial terms and conditions, and actually also delivered using the same processes and systems, which meant that things need to be separated quite deeply within the business. Now, what actually happened following the launch of OpenReach was it massively stimulated competition in higher layer network services. Local loop unbundling hadn't really happened on any great volume before the creation of OpenReach. We had about 150,000 lines which were unbundled loops. I'm going to explain that later in case you don't know what that is. But now we're over 6.7 million lines, and there was a huge growth in competitive market-facing propositions from all of those brands that you see there. So our lines underpin all of those brands to some extent, and these are the key brands in the UK marketplace for broadband communications. Now, it's not only LLU, it's also Ethernet backhaul services. So we provide local loop unbundling, we provide the ability for operators to put their equipment, their exchange equipment, in our buildings, and then we give them the capability to backhaul that through high-capacity Ethernet links, 100 megabit, 1 gigabit Ethernet backhaul links to their more centralized points of presence. And I guess that's been a catalyst for industry innovation. So all those free broadband propositions which happened in spring to summer of 2006 stimulated growth of the broadband marketplace. And the consequence of that is that UK broadband availability is amongst the highest in the G8. But I guess that you'll also be familiar with the concerns about speeds and rates, and a lot of the hype about speeds and rates. So I'm going to try to discuss some of that as we go forward as well. So that's a bit about OpenReach. Content of my talk today, a little bit of orientation around the OpenReach access network, the fixed access network and its history. Then I'm going to take us through a little bit of a case study around next generation access, the things that we were discussing in 2007 as the basis for the business case and the motivation for driving what turned out to be a significant investment for BT, £2.5 billion for next generation access. Talk about the relationship between fixed and mobile communications and how I see these as being quite complementary, with fixed delivering the highest bandwidth density and mobility being enabled by the wireless networks, and indeed growing convergence between those two things. Bit of a discussion about what this enables, and if you're moving into the telecommunications industry and a lot of your activities in the software space, it will be about how you create software-based applications to exploit the capabilities of future multi-service networks going forward, and then talk a little bit about what I see as being future challenges. And hopefully if we can make that a little bit interactive, then I can pitch it in a way which is meaningful for you. So, a little bit on OpenReach access network and its history. So in order to illustrate this, I found an old picture. So because it's this access network was laid down to underpin voice telephony services. So basically, within that access network, within the exchange, typically you'll find what is a main distribution frame. Have people heard of, seen of those things? It's where all the copper cables are terminated, all the individual lines are terminated, and then these pairs run through cables, sometimes big cables, into an exchange manhole, through what we call the E side or the exchange side network, main cables. And there's an example of a main cable here, which is a 1,000 pair main copper cable, which is where your broadband would typically run down. You can have a look at that later. To a green box in the street, which is called a primary cross connection point, which is an area of flexibility, which then the D side cables run through towards homes or businesses, and often delivered through an overhead drop wire from a pole which is on the street side. So that's a bit of an orientation around the copper access network, and what I'll do is I'll build on that as we move on. Some numbers on that from the UK network, just so you get a sense of the scale. So that talks about the main distribution network, about 5,500 exchanges. So the exchanges were really located according to the density of lines within the access network, and according to the limitations, the range and reach limitations from voice services as these were originally delivered. So typically the reach for voice service was about 6 kilometres. Some are a bit longer than that. But then that led to 5,500 exchanges, some of them in cities, in the urban centres, very large, tens of thousands, even 100,000, and some of them in rural areas, pretty small, maybe only 100 lines or so. So then cable segments on the E side, average length about 1.8 kilometres to the cabinet. D side, average length about 500 metres. That will become important later when we talk about VDSL, because VDSL won't run the full length from an exchange, but it will typically run from one of those active cabinet, one of those cabinets to the home. And then final drop, perhaps 30 metres. Just so you get a sense of the numbers, these green cabinets, about 89,000 now. These distribution points, about 4.3 million. Joint boxes, 4.7 million, 59 million metallic pairs, 32 million working lines. Average loop length, 2.3 kilometres, but up to 6 kilometres. So it's that variation which is quite important when we talk about broadband going forward. Okay, so that's a bit of orientation. And that access network was used first for telephony. So it was voice telephony, and originally it was all operator connected, just connect wires to wires. That then subsequently was replaced by electromechanical systems, people familiar with that, something called Strowger. If you're interested in that, I'll do a bit more of that this evening with the IET lecture. But in the 80s, these were all replaced by digital switches, stored program control switches. And this particular example is System X, and that was my introduction to telecoms. I worked on the development of this stuff with a Plessy company in the 80s. And really that was motivated by cost and quality, circuit switched with analog to digital conversion at the edge, pulse code modulation, familiar with that stuff, A-law and all that kind of stuff. And that coupled with the fibre optic capabilities of fibre optic transmission massively reduced the cost of introducing that kind of switching capability into the network. Prior to that, it just wasn't possible to have any competition in the market at all, because the cost of owning, maintaining and operating equipment and having the number of operators required to make calls was something that couldn't be replicated at all. So from the 80s, we had a period of something called the duopoly. So there were, but that duopoly wasn't actually in local exchanges. It was actually only in the trunk exchanges and long distance exchanges. So that started what has been quite a significant journey in the telecommunications market in UK in terms of competition. So BT and Mercury, part of the duopoly, and if you look at the way in which this equipment was used, from the telephony on one side through the access network to a concentrator, 2,048 lines, to a local switch, maybe about, as I said, 5,000 or 6,000 of these, to trunk switches, maybe 70 to 100 of those. It was that trunk switch and international switching which was the area that competition first started in the UK. And to make a call, the call would be circuit switched from the concentrator at this edge of the network through local, trunk switch, local, and concentrator to the other side. And I've used this little symbology here just to indicate the access network as being a common, being something constant, just so you get a sense of that. Now, in the 70s and 80s, data over those, this was essentially a voice network, but data started to become prevalent in the 70s and 80s, perhaps a little bit earlier, with voice band modems. People have seen these kind of things before. Are people nodding? Yeah, so this is a 300 baud modem, 300 bits per second roughly, and that indicates that it is actually in the voice band, because all you did was you pushed the receiver and the transmitter into the opposites in the modem, and 4 tones, noughts and ones, were transferred in the receive and transmit direction once you'd established a call to a computer host. That was the way it worked. Now, of course, those modems got a little bit better shortly after that, in that we ended up moving on beyond 300 baud modems up to 56.6 kilobit modems, and that became the basis of voice band access to the internet. But in 2001, 2, and actually that's only in this decade after all, broadband took off. And the same access network, but higher frequencies. So baseband was preserved, but above 4 kilohertz, which was the upper limit really of voice telephony circuits, DSLAMs in the first generation used to drive signals up to 1 megahertz with ADSL technology, sometimes called ADSL1. People familiar with that? ADSL? Has that been part of the courses? Yeah. It's mentioned. Okay, so we'll talk a bit about that later anyway, so you get a sense of that. In essence, what those DSL modems is, sometimes I think it's some of the technology which is closest to rocket science and telecommunications these days, is the way in which you can deliver very, very high bit rates over quite noisy and lossy copper loops. And essentially the way it's done is using technology called orthogonal frequency division multiplexing, which breaks the signal down into a set of different buckets, about 4 kilohertz each, across the frequency range, and then through sophisticated digital signal processing is then able to deliver communications reliably across some noisy links. So that just shows the way this thing works. Concentrator with the voice switching on the baseband, but a DSLAM in the exchange connected through an asynchronous transfer mode network through to BRAS, or broadband radius access server, which has access to the internet, and that provides the ISP-based service. But again, the access network still the same. Second generation broadband was really enabled by something called local loop unbundling. So I talked to you about the main distribution frame. This is an example of a main distribution frame and exchange. You get a sense of just how many wires are being terminated in the exchange. This became the flexibility point for the industry as the industry drove from 2006 for the unbundling of local loops from about 150,000 lines to 6.7 million or thereabouts is where we are at this stage. And the way that local loop unbundling works is at the exchange at the main distribution frame, CPs are able to install some of their equipment, and then that connects northbound into the rest of their network, and then they're able to adopt those loops either in something called the full metallic path format. They have the loop, both the baseband and the high band, or in something called shared metallic path format, where they take only the high band and voice continues to be delivered using a product that we call wholesale line rental. So in essence, what that does is that allows communication providers, CPs, to put their equipment in some of those exchanges In practical terms, they've gone to about 2,000 exchanges, not the 5,500, because the economics don't really work for very small sizes. And then that allows them to adopt those lines and then deliver broadband service to end users, and indeed telephony service where that's what they want to do as well. Now, typically, they use technology called ADSL 2+, and ADSL 2+ was really the second generation of ADSL, asymmetric digital subscriber loop technology, which was used, and ADSL 2+ uses roughly a 2 megahertz carrier, and that is then able to drive more bandwidth down those loops. But because higher frequencies attenuate more rapidly on those copper loops, it means that if you've got a shorter loop, then you're likely to get quite a lot of benefit from ADSL 2+ from the higher frequencies. But if you happen to have a longer loop, then it might make very little difference to you at all, because all the benefit of the higher frequencies is lost. So, that's a bit of a background. I now wanted just to take you through some of the thinking process that we went around from about 2006, 2007 to generate the case for next generation access in the UK, which is actually one of the biggest cases we've ever tried to make. So, just so you get a sense of it, and this was one of the pictures we were using at this point in time, where we tried to provide as it were, a two-dimensional view of applications and their bandwidth characteristics and their quality of service characteristics in broad terms, such that we could orientate people's thinking about the things which were actually changing in the industry. Because you'll be very familiar from your own experience of broadband in the early days, where broadband was simply about providing access to the internet, and quite often it was, even before broadband, internet was actually about text access to web pages. And then with the dial-up access, you used to get frustrated because you saw the words just sort of scrolling down the screen, and it was all very, very slow as it was downloading. But then fairly quickly after that, then pictures became part of the piece as well, and that was even worse, wasn't it? Because more bandwidth required to deliver more data being transferred, and that picture taking all that time to scroll down the screen. So when broadband was introduced, that was a bit of a revelation. Suddenly, those screens dropped down on your those images dropped down on your screen immediately. The broadband rate was truly transformational, and you could actually make voice calls while you were on broadband as well. So that was a plus as well. So just so you get a sense, standard internet access applications are probably in this space relatively low bandwidth requirement, relatively low service requirement. Doesn't matter much whether there's bit errors or whatever, because the TCP IP would correct that and would pick that one up. But if you wanted to do something like voice over internet protocol, then the interesting thing is the bandwidth requirement isn't that high, but the delay requirements can be a little bit more stringent, so need to be more familiar about that. Delay and jitter errors can be fairly tolerable with that kind of thing. The most exacting things that we are seeing right now are probably some of those things around this video telephony, video conferencing, because it's a bit bi-directional, and the HDTB being the most demanding stuff that we're seeing around there. Some of the gaming applications, the way these are being framed, low latency becomes a key requirement. But we were using this as a kind of way to describe the applications, and to people that didn't fully understand the nature of the quality of service and bandwidth differences that these applications required. And then what we also did was we did quite a lot of modelling work around ADSL and ADSL 2+ performance on our network. So what those graphs show, and this one is I'm sorry if you can't see it, but you'll see the slides later, you'll get a sense of what is the percentage coverage across the network, and what is the bandwidth which is typically delivered. And this is based upon a set of models that we've got, which are line loss and crosstalk noise models for the whole of the UK network. So in essence, what we're then able to do is then to get a view as to what the likely rates are going to be. And I'm going to describe this a little bit later, but just so you get a sense of somewhere about 4 or 5 megabits is the median rate across the network, so that's the 50% level for ADSL, and something around 8, 9 is the median rate for ADSL 2+. So ADSL, the speeds that you get dependent on line length and line quality, performance limited by crosstalk from other end users, other pairs in the same cable bundle. But the actual performance will depend on the noise environment for an individual pair all the way through the run of that pair. So if you've got a pair in the middle which is surrounded by other DSL lines, then it will suffer more crosstalk. If you've got a pair on the edge, which doesn't surrounded by quite so many, it will suffer less crosstalk. And if there's less crosstalk, you will get better service, even though the pair is longer. So every end user is really in a unique situation, and it's not just about line length loss and noise, insertion loss and noise. It's also things like modem and configuration options, the way these are framed. End user wiring can have significant impact as well. And if the end user wiring in the home is of poor quality, then it can pick up quite a lot of noise and adversely affect service, which is why we've done some work on service-specific faceplates. Sometimes these, if you've seen these things in the home, this is the NTE. People are nodding, seen that. When you can actually get some service-specific faceplates which are alternatives to microfilter type things, which you're probably familiar with, which can isolate the high-speed service from the low speed at the point of access to the home, just by installation of a service-specific faceplate like that one. Put it the right way around. So, talk about that later if you want to. But what does that actually mean? So, putting some of that together, and this was one of the things that we were given an example. So, mapping that into my country, Scotland. We were looking at sort of standard browsing in Scotland, where we assumed that it was something like 512 kilobits per second, and with pretty good coverage across most of the country. A few red spots, which are the not spots, you know, where there's a problem, but by and large, not too many people live there. And the white bits are the locations where nobody lives actually in Scotland, but that's where quite a lot of Scotland's white, of course, today with the weather, but there you go. But then when you looked at, if you wanted to do standard definition TV, where we'd assumed that something like 1.5 megabits, 2 megabits was the threshold, you're starting to get a lot more red there. But if you wanted to go to HD TV, where we assumed 8 megabits or thereabouts would be the minimum requirement, with ADSL, most of the country, Scotland, most of the lines in the country couldn't support that. Gets a little bit better with ADSL 2+, but still not there. So just to give a sense, so we were using high definition TV streamed over broadband over our lines as part of the vehicle for explaining what could be delivered and what couldn't. But in 2007, we were also asking ourselves a question about, is there really a demand for the high bandwidth products? And this is actually a table that we put together in 2007. So that's why I put this thing saying dangerous predictions, because the one thing that we were very clear about that was that whatever we were saying, it was wrong by definition. It was a prediction. But in essence, this was giving us a view of what we called unconstrained bandwidth demand. So this was if people would state they wanted it without really understanding how much and whether they could actually afford it at that point in time. And really it was all about, for consumer consumption of video content, including HD, TV, IPTV and VOD. Remember in 2007, iPlayer hadn't been launched at that point, so it was a concept. There were a few people playing with it, but it wasn't actually a mass market concept that anybody understood. For small to medium enterprises, you're seeing increased use of network-based services, but by and large, the bandwidth demands weren't all that high, quite often looking for more symmetry than downstream rates. And large corporates certainly wanted it, but that was where you were not serving it by existing broadband lines, you were serving the large corporates with fibre access in the place. But the constrained bandwidth was much, much less clear because what we were saying is end users, we were very uncertain about what end users were prepared to pay for this. In fact, we were pretty sure that end users didn't want to pay much more for having a lot more in terms of capacity. So that was one of the predictions. By 2011, over a quarter of the consumer market will require peak download speeds of over 20 megabits. I don't think that's too bad. People would recognise that that was quite a reasonable prediction. But we also looked at the nature and the structure of our industry, and we were starting to think about how we needed to put things together in order to make a case that worked end to end. And this, because OpenReach really is providing infrastructure services, and as a provider of infrastructure services to the industry, we can attract the high retail premiums. And we wouldn't be the folks that would deliver the IPTV propositions and attract the revenue from that, you know, if that was Sky Sports or whatever. And these little diagrams are really giving you a view of what we call the perceived value across different layers of the network, whether it's the access network, the core network, signaling, value-added network services or applications, with most of the value being perceived in the applications. People don't buy infrastructure, they buy the capability that that infrastructure delivers for them. But actually, when you look at the costs, they run the other way. It can be fairly cheap and easy to add an application server to deliver over the internet, but the costs of upgrading the access network can be phenomenal because lots of civil engineering involved. So we had that stuff in mind where we were thinking about the key investment imperatives for OpenReach, where we wanted to secure sustainable investment in that horizontally segmented value chain. So that's where we are really the access provider, and we underpin communication providers higher up that value chain. We needed to think about how we would do that in such a way that we'd maintain our cash flow for the business. We could see that demand was growing, and we could see that we would reach the point in time where our network couldn't cope with that demand because we could see the capabilities of technology. And we were trying to find a way in which we could focus access investment in business and technology with a long-term future for us. Just to pick something up from the BBC here, just because, you know, is that demand growth actually happening? And the answer clearly, unequivocally, yes. And you can read all sorts of marketing reports, you know, where people are predicting or reporting back what people are saying about the bandwidth is actually being used. But as an engineer, I prefer to see some things which are based on tangible and unequivocal measurement. And this is actually data from the BBC, which actually shows the bandwidth in petabytes, that's 10 to the 15 bytes per month, from April 2008 through to just about January 2010. And that shows, and that's mainly driven by iPlayer, because iPlayer was launched in about December 2007, at Christmas. And iPlayer traffic growth is one example. That shows 7-fold growth in that 20-month period, from 2 petabytes per month to 14 petabytes per month. And that's the measured stuff that they were saying. So that's not hype, that's reality. We were looking at next generation access network options and what options were there, understanding what you could deliver ADSL from Exchange or ADSL 2+, where they've got headline rates and then there's indicative rates at that time. We know a bit more about what these things can do now in terms of what they can deliver. We're also looking at things like fibre to cabinet. We'll explain that one later, which is where using technology called VDSL2, which has the capability to drive frequencies much, much higher than 2 megahertz on the bearer. And actually the band plan that we use in our VDSL2 now is about 7 megahertz, but it can run up to 30 megahertz. But you can only run that 30 megahertz on much shorter loops, so that's why we're running a 7 megahertz one at this point in time. But that was looking at, you know, median rates in the 22 to 30 at the target cable fill. We're looking at fibre to premise type options, and then positioning some of the more competitive propositions, satellite broadband, broadband terrestrial digital TV, so you get a sense of what that is, and wireless through HSPA and WiMAX type capabilities. Now, of course, mobile broadband hadn't launched at this time, so just so you get a sense of it. But we were trying to give an indication as to what the headline rates were claimed to be, what the median rates would actually be, and what the relationship to our current networks might be. So when we were looking at some of those options, and these are just the graphs I showed you a little bit earlier, in terms of on cabinet, what we call cabinet served premises, which is about 89% of the premises in the UK. We were looking at the predictions of speeds on copper from models of line length and noise. So with ADSL, the dotted line is actually the 95th percentile in the distribution of lines from the noise models, which actually turns out to be pretty close to the best predictor of the things that we see, because it's not just line length and crosstalk noise. There are extrinsic noise sources and there are line quality issues which tend to skew the numbers down a little bit. So that shows something like the 5 megabits is the median rates in ADSL, about 8 to 9 megabits as the median rates of ADSL 2+, and it shows that on our noise models for VDSL where we think we could get to with fibre to cabinet type propositions. So I'll explain some of that a little bit later. But we're also clear that it wasn't just about speed. Quality of service and other attributes were key things. And I don't want to go into this in great detail, but you know, this is stuff that you can have a look at. So we were trying to look at things like bandwidth variation by line, because one of the problems with DSL, because these copper loops were designed for voice and they got reliable transmission characteristics across the full distribution for voice. For DSL, the speed you get, as you know, depends. So bandwidth variation by line creates problems from the perspective of marketing. If you look at things like ADSL 2+ gives a view about the extreme range, you know, from half a megabit or failure to sync up to about 18 megabits. Fibre to cabinet, you know, we could get 10 to 30 or more. Actually, most of the fibre to cabinet lines that we're deploying now are in the high 30s, 38, 39 at this point in time, in the sync rate. Fibre to premise, negligible variation, much more predictable thing to deliver. But extreme variation means that you've got a very fragmented market and difficult end user expectation setting. So we all know that. Bit error rates, they're really driving link stability, but high bit error rate means picture degradation, temporary loss of communication. Things about reach and range. We were also looking at things like how easy is it to provide service, so provision and churn. And we're going to talk a bit about OSS, operational support systems, later on, so you get a sense of that. Also views on fault rates and views on faults of costs of network upgrades. So relatively low if you're going to put ADSL into exchange, ADSL 2+ into exchange, mid to high for fibre to cabinet, but very high for fibre to premise because there's a lot of civil engineering, a lot of new cabling required. So that takes us back to the demand perspective in a sense. So we created a concept for future broadband, which we called the mixed economy, which is the ability to sell different services based upon different technologies and different geography, but where practical, delivered from a common technological base. And I'll explain that in a minute or two. So in essence, the way you deliver higher rates with next generation access is you reduce the length of the copper that you've got to drive signals over, either to a few hundred meters, that's the fibre to cabinet scenario, or eliminate it completely, at least as far as the edge of the house, through fibre to the home. And I'll explain a little bit more about the proposition later. So what are we doing now? So that was the 2007 debate, and that was the way in which we justified in sort of technical and demand sense. I've not shared the business case numbers with you, but I've explained the basic rationale that we went through. So what are we doing? We announced a $1.5 billion investment to deliver and deploy next generation access to about 40% of the homes in the UK by 2012. And then we announced this year an expansion of that programme to £2.5 billion investment to reach something like 66% of the premises in the UK by 2015. So these are big amounts of money, and we're delivering something that we call the mixed economy proposition, a mix of fibre to cabinet and fibre to the premise, depending on the costs of delivery into a particular geography. Because we are a business, and as an engineer I'd like to deploy fibre everywhere, but as a businessman I have to be realistic about what we can actually afford. So the approach that we're taking is something that we call Ethernet active line access. And if you're interested in this, you can look at some of the NICC standard Network Interoperability Consultative Committee standardization efforts, where it describes the way in which those products and services are put together. And in essence, what we do with that Ethernet active line access is we try to provide an active means of delivery of next generation access, which supports multiple communication providers, which is open to innovation from those players. It's mixed economy, so what we call fibre to the X, fibre to cabinet, or fibre to premise. So when you see this picture, and I'll explain it in a little bit more detail, you'll see that there's some parts which are served by fibre to cabinet and some parts which are served by fibre to premise, but there's a common head end and optical fibre stuff at the exchange. It's part of BT's £2.5 billion investment, and the headlines for that are 4 million UK homes passed by this month, and 10 million by 2012, with 66% coverage. That's about 15.6 million homes by 2015. Now, all of that so far is BT's investment, but because this is open access, it also can qualify for state aid funding, because it underpins the industry in a common wholesale basis. And we were successful in Cornwall, where there's a 132 million investment. Something like 70 million of that is BT's, and about 50 odd million is EU funding. So you get a sense of how that works. So in essence, the base case is ours, but to get to some of those sparse and difficult to reach geographies would require additional investment beyond our base case. We couldn't make our cost economics work in that case. So in actual fact, the way that the gap funding works is that there's top-up funding, as it were, which comes from in that case, from the European Union, which covers the gap between our base case and that which it's actually going to cost. So simplified diagram there on the fibre to the X-access infrastructure, and something's gone slightly wrong here with the head end, but in essence, either fibre to cabinet in certain parts of the geography, or fibre to premise in other parts of the geography. Now, the way that the fibre to cabinet piece works is we've got one of those existing primary cross-connection points in the street, which is a flexibility point into the copper cable. We build an active cabinet adjacent to that, which has got DSL equipment in it, and this is VDSL, which drives signals over 7 megahertz on the D-side pairs. There's a tie cable between that existing PCP and the active cabinet, and when a customer wants service, we effectively jumper across at the tie cable to connect the VDSL onto that loop. We install a server-specific faceplate in the home, because otherwise, with the higher frequencies, with unfortunate resonances that we get with those higher frequencies because of the spacing in extension sockets, if we didn't do that, then the service would drop significantly. We install one of those server-specific faceplates. Then we install an OpenReach ADSL, VDSL2 modem, which has Ethernet ports out, and the communication providers connect into that via their set-top boxes, their home hubs, and the like. In fibre to premise, the model that we've taken is something called passive optical networking, and this is a simple model. There's a single stage 32-way split. What that split allows us to do is to deliver service more cost effectively. It's some tens of % cheaper than point-to-point fibre. And what that means is that we have reduced port counts and reduced power and reduced fibre counts up in this part of the network, but then we can connect all the way through to the endpoints there. And this is a slightly more complicated diagram, which I'd be happy to explain to you what all the plant and practices are around there. And indeed, I've got some of the kits or parts that we have here, just so I can explain that in a tangible way, if you're interested. Now, I understand that a lot of you folks are working at the software end of the communications value chain, as it were. But I think it's very important to understand how that software relates to the physical media which is delivered across, and how that physical media, in the way it's delivered, constrains the things that can be delivered. So, why have we done it? Why have we done it that way? As I said, growth and demands for speed and quality of service. People wanted to move from just scrolling text down their screens on their internet access to sound and then video with the iPlayer type experience. And we wanted to deliver next generation access capability to communication providers at the lowest practical but economical point. So we created an open access network. We wanted to create something which was kind of similar to LLU, but practical in this next generation world. It wasn't practical in a commercial sense for communication providers to be digging up the streets themselves or building in active cabinets themselves, despite the fact that we've had a product for a number of years called subloop unbundling, which enabled them to do that. Really hasn't been taken up. We wanted to create a base level capability which could then be used to support higher level innovation by communication providers. So we needed to find a way in which we could support that with the right kind of systems capabilities, which would support things like fulfillment, assurance, billing, enabled by something that we call the equivalence management platform. Effectively, when we created OpenReach, and I mentioned this previously, we said we would deliver services on an equivalence of input basis. What that means is we deliver the same services to communication providers that we deliver to BT, enabled by the same processes and systems that BT use. So we've created something called the Equivalence Management Platform, which is a huge business-to-business trading platform, which deals with things like pre-order, order, troubles, appointing engineers, running diagnostic tests on the network, things which enable them to launch their services on the basis of the components that we deliver. So that's what Equivalence Management Platform does. So the approach we took was to create something called an Ethernet bitstream product, active line access, which gives us the option for physical media independence. So we can deliver Ethernet service based on either fibre to cabinet with VDSL or GPON based fibre to premise. And of course, as Ethernet, it will deliver all the full range of applications: voice, broadband, data, best effort data, and video. So how are we doing that? So we're enabling processes across the value chain. Our product is called Generic Ethernet Access, and the fibre to cabinet variant is the one which is already launched. BT Infinity is launched and is currently delivering over 4,000, approaching 5,000 lines per week on that platform. TalkTalk Group have announced that they will launch in the near future, and of course TalkTalk Group are in the Salford area, Idlum, down the Manchester Ship Canal, so great customers of ours. And we've got about 5 or 6 other major network heavy communication providers trialling very intensively with us at this point in time. In order to underpin them, we are scaling our provisioning processes, what we call lead to cache, and I'll explain that in a minute. What we call lead to cache, we're scaling our provisioning processes with them, and trouble to resolve. So when we've deployed it, we have to be able to fix this thing in the right way and deliver the right quality of service. This is a premium proposition relative to exchange-delivered broadband. And the other thing that's worth noting is that OpenReach not only holds all those lines, but OpenReach has something like 25,000 folks that drive around in vans, and you've seen the OpenReach vans, and our folks do the installs both for our own equipment, that's installing the OpenReach boxes, but we do a managed install on behalf of communication providers as well, where we install their set-top boxes, we install their home hubs, and we check that all of the high-capacity services are working properly for them. With fibre to premise, we're a bit further behind, a lot more complicated, a lot more work that's required. It's about 3 to 4 times the planning effort relative to fibre to cabinet, and a substantial amount of additional work, so more capital intensive. So we're doing a lot of work to prove plan and build processes, and proving incremental lead, cache and trouble to resolve processes for a new network build, with a range of delivery models, because we need to find ways in which we can deliver that new network using the existing physical structures, whether that's duct or overhead routes, because we don't want to incur the costs of digging up the streets unnecessarily. So, range of delivery models, some of the accesses to homes are underground, some are overhead, some are in multi-dwelling units, that's what MDU is, and we're busy on all of that stuff right now. A roadmap, we're adding multicast capabilities into our Ethernet service to support linear TV propositions for communication providers. We're adding something called fibre voice access, which effectively, in the fibre to premise, when you don't have copper, you've only got fibre, that's a fibre cable. The way to deliver voice is through having something called an analog telephony adapter in the optical net associated with the optical network termination. So in essence, this is the optical network termination for fibre to premise, and it's got a couple of telephony ports which can be controlled and managed by a call server from any of the CPs that choose to integrate with that. So they will have control over that. So that's what fibre voice access is all about, and a bunch of other things, including lower cost cabinets. So just so you get a sense of the architecture that we've developed for our next generation access propositions, a common optical line termination, whether that's fibre to premise or fibre to cabinet. Communication providers will integrate using 1 gig or ultimately 10 gig links and be able to address any of the endpoints on this network using VLAN technology, delivering the right kind of quality of service end to end. So far, this is point-to-point stuff is part of our business as usual proposition, but in the in the generic Ethernet access area, the way that we're working on this is we're doing the gigabit passive optical networking technology options and the street cabinet DSLAM options. We're not doing some of the deeper options yet. And I think that says pretty much what it is. Just so you get a sense of the product propositions, and I won't go through this in great detail, but you can have a look at that if you're interested. But it basically outlines some of the service characteristics of generic Ethernet access over fibre to premise, fibre to cabinet, where our peak rate service for fibre to premise and fibre to cabinet is 40 megabits at the base level or downstream. We've shown that as 40 megabits for fibre to premise. We've shown that as less than 40 megabits because it's actually an up-to service, although for VDSL, because that's the nature of VDSL, you can't offer guarantees with the technology. But what we do offer is a guarantee that we will select lines that have at least 15 megabits, which enables at least one HD session and can run concurrently with a couple of SD sessions as well. So there is that sort of capability. Now, and of course, some of that technology, as you move into business and other areas, we can offer fibre to premise premium propositions up to 100 megabits. We've actually got this interesting one, which I'll just, as telecommunications or communications engineers, you'll sort of get this stuff. We've got a premium proposition at 110 megabits. You'll say, why did we do 110 megabits? And we say, why would you do that? Well, actually, it's because in the consumer market, with things like speedtest.net and Sam knows and those things, people measure throughput at the TCP IP layer. And we wanted to be able to offer something which allowed our communication providers to offer something that would deliver 100 megabits at the TCP IP layer throughput end to end. So in order for us to be able to do that, we had to offer something at the Ethernet information rate at 110 megabits. Now clearly, you have to have 1,000 base T ports here, and you have to have 1,000 base T ports to deliver that, but that's the kind of concept. That's why it's there, because the consumer market measures things now in the UK using things like speedtest.net at TCP, even though the business market sort of understands the difference between Ethernet line rate, Ethernet information rate, and then the higher protocols beyond that. So I've talked a bit about what it is that we've been doing at the network level. We've been doing quite a lot of work in OSS. When I had a chat with Nigel about this one, he said that quite often in university you have a little bit difficulty getting access to information about the kinds of things that are built within communication providers around operational support systems. So in essence, I put 3 or 4 slides in here just to give you a sense of the kind of things that we've been enabling through OSS to build the logistical capability such that we can sell our products and operate and maintain our products for our customers. So the key systems and processes that we've been working on have been in the plan and build, which is about the things that we need to do to build the network ahead of orders. Lead to cache, which is an extension beyond provisioning or fulfillment, if you're familiar with that terminology. And why we call it lead to cache is it's meant to cover the whole of a customer journey from the initial lead, the initial contact, through to the point that we are able to bill for the product. Trouble to resolve, same end to end from the customer perspective. And it's really about underpinning the right kind of customer experience, which is getting things right first time, getting the cycle time short, getting the unit cost right, and getting customer satisfaction to the right levels, and underpinning whatever service level agreements that we've got. Now we're using Agile development methods for this, and everything starts with the right kind of customer engagement, story decomposition, which allows us to work in a hierarchical way and make sure that we can trace our requirements through to the things that get implemented properly in software terms, and to make sure that we've got the accountability for delivery properly delineated. It's done within an architectural framework, so we've got a set of reusable components which underpin our OSS generally, and what we're doing is we're augmenting those and reusing those in order to deliver services. We do continuous integration and test, which means that with Agile methods, what you try to do is you try to write your test specifications for the software before you write the software itself, such that you can test it as you go. And then once that software is all deployed, it's about change deployment into the business. And I've just given you an example there in one area, so that's the plan and build. And one of the things that we've done is something we've called the network engineering journey. And most of these OSS don't have very interesting screens. Mostly it's transactional in nature, so you can't see much happening. But some of the plan and build systems are a bit more interesting. It shows the location and presence of plant and capability in the street. And that's really all about planning efficiency, process benefits, better quality for fibre cabinet and fibre premise, reducing our network costs, better cost estimates, ultimately with that data supporting improved targeted marketing and enabling the ongoing operation of the network once that's deployed as well. And we were very pleased when this thing was awarded UK ID Industry Awards for 2010. Just to give you a sense of the things that we do for the fibre to cabinet lead to cache, some of the services that we deliver, predicted and actual bandwidth on lines, port availability, checks on compatible or incompatible products that are on those lines already, dealing with appointments, dealing with initial provision, depending on what the starting state is. Is it a wholesale line rental line, or is it a conversion from an existing broadband line? modifications, CCs, amendments, MIS, something called dynamic line management. If you want to get into a fairly arcane area in VDSL, this is some really sophisticated management capability which allows us to manage the noise floor actively around DSL systems and thereby improve its efficiency. Some very sophisticated things, and some of that stuff will lead in the future to a very sophisticated technology called vectoring, and we'll come to that in a bit. Trouble to resolve. We deliver test and diagnostics capabilities through portals and business-to-business gateway, which allow communication providers to test lines when things go wrong to determine whether it's a problem in our domain or their domain and improve efficiency. So things like port status transmission, modem status, copper line tests, appointments. So our communication providers can appoint our engineers. We can create and progress faults. We can do special faults investigations. We correlate alarms, so people will be familiar with that. We do performance management, statistics and trends, and we manage major planned outages on the network. So you just get a sense, a lot of stuff needs to be built into the logistics of the firm in order to allow us to deliver this at scale. Remember, we were trying to hit something like 4 million homes passed, and we are now deploying over 4,000 a week at this point in time. So we got tens of thousands of customers that in this year that will grow to hundreds of thousands. You need to have logistical capabilities which can support that at scale. So what next from this? Demands for speed, quality of service will continue to grow, and indeed the base technology we're working on will evolve. So we're already looking at ways in which we can improve the scale and performance of the head end. So that's got an integrated Ethernet switch capability. We're looking at the evolution of VDSL2 technology. There is a potential to bond multiple pairs and then get a simple multiplier on the bandwidth. I mentioned vectoring previously. Vectoring is a kind of noise cancellation mechanism, and provided vectoring applies to all of the pairs in a copper bundle, then you can cancel out some of the crosstalk noise. It's a bit like if you're familiar with the Bose headphones that you have on the airplane, where it picks up the noise from in the airplane environment and feeds that back in antiphase to cancel it out. So it's a bit like that, but it's about all the signals, all the DSL signals and all the bit buckets managed. We're looking at the evolution of GPON technology. So the gigabit PON is a common bearer of 2.5 gigabits downstream, 1.25 gigabits upstream. But the next generation from that will be 10 gigs downstream, so a big multiplier. We have already planned, where we deploy fibre to premise, to be able to support the XGPON system alongside the GPON in parallel, such that we can support hitless upgrade. We're enhancing our Ethernet backhaul propositions. Our 1 gig services volumes grew about tenfold this year, a lot of that driven by mobile broadband, and fixed and wireless alignment. I said I would say something about that. Is something that we can see an opportunity for this as well. Some of this NGA stuff could support some of the backhaul requirements for more dense cell deployment. So, NGA deployment, some conclusions in our market environment. Most global next generation access solutions are currently being deployed by vertically integrated players. Now, I think I explained earlier this issue about OpenReach and its horizontal segmentation and the way in which the value chain needs to work. So NGA in our model, which has got this functional separation, makes things a bit more difficult. So we need real clarity around the regulatory environment. We need to think about how we actually manage the business models for ourselves and for our communication providers, such that we can both win in this. So with us winning in OpenReach on the long-term case for creating infrastructure, and the communication providers creating cases to sell new high-value propositions which use the higher speeds and quality of service that this network can enable. The other thing that's worth noting is that this thing won't fly unless you get enough volume, enough scale and pace in the marketplace to get people excited about, which is part of the reason why we're pushing so hard to get to 4 million homes passed by Christmas this year. Most of our communication providers, network heavy guys, said, well, we'll get really interested when you get to 4 million. So there you go. But that 4 million deployment is 4 million homes passed. There will be a percentage take-up, and it will be a percentage take-up on the end users that want and need those higher speeds, because not everybody will want that. So we would expect to see a mixed economy model running for some time in the future. So that's a bit of a story about NGA. I just said I would say something about mobile, because the future of our networks is fixed and it is mobile. And I wanted to start with something that came out of Ofcom's net neutrality consultation. And effectively that purple line there shows bandwidth volumes growing on mobile networks, and that green line shows revenues. And it shows, in essence, that traffic has increased 20 times in 2 years, but revenue has increased 2 times in 2 years. And that's not actually a good position if you're a network operator. So key mobile network operator requirements for us are actually to reduce the cost per bit and increase the network capacity. So interesting challenges. What's driving that? It's mobile video bandwidth. You're probably familiar with all those things. And that's a nice little build, I think, from the devices. 200 kilobits on a video on a Nokia E50 to something like 2 megabits on an iPad with 1024 by 768. So you'll be familiar with those, including iPhone 3, the one I've got, and iPhone 4s. And that's not going to be where it ends, because tomorrow's displays will need more. So you can see those, you can see that the mobile operators are selling those things very rapidly, and they're creating a demand on there, but their network capabilities are struggling to cope, I think it's fair to say. So then the issue for them is how do they find ways to increase mobile network capacity? So some of the things they can consider, they can use spectrum more efficiently, and certainly better air interfaces using multiple antennas, LTE, the long-term evolution, which is the next generation, which will not happen until after 2012 auctions, if the auctions happen. But there isn't much to do, because 3G is already fairly close to the Shannon limit, and there's a limit to how many antennas you can fit in. You can use more radio spectrum, or refarm some of the existing spectrum, which is also some of the things that are being done. But there's a big cost ticket associated with that, although I very much doubt that we'll see the heady heights of 22 billion, I might be wrong, that we saw in 2012 for the bandwidth which was auctioned then. But the available spectrum is limited by laws of physics, and some spectrum's better than others. Yeah? So people are nodding, so you're familiar with some of that stuff. Or you can divide large cells into smaller cells. So there's a little build on that one, and deliver higher bandwidth density of that. But every one of those small cells requires backhaul. And that backhaul is typically best served by fibre if they can get it there, but opportunity for next generation access if we're deploying reasonable capacity in there. Fixed lines will always deliver higher bandwidth densities, that's for sure. Or offload onto other networks like Wi-Fi. So just as a sense, I mean, if you've got one of those smartphones, you'll know that it works best when you're on your home Wi-Fi. It works next best probably when you're on something like OpenZone, if you've got that, which is Wi-Fi offload, and it doesn't work all that reliably on 3G at this point in time. So there's been quite a business on Wi-Fi, and if there's something like 40,000 public Wi-Fi hotspots. People look around for those kind of things, but there's something like 60 or 70% of the broadband home hubs in the country are actually Wi-Fi enabled. So that creates another opportunity, which is why things like FON have been created. People familiar with FON? So FON is a means by which Wi-Fi capacity can be shared in a secure way, in a relatively safe way, across people's personal Wi-Fi setups. So you can get phone apps on your iPhone these days as well, provided you're part of the phone club. So that just gives a sense of the wireless access technologies. I didn't really want to get into that, but actually I think that we saw some of the same kind of thing in mobile broadband that we saw with fixed broadband, where people got a bit bemused by the headline rates. But actually the headline rate on mobile broadband is actually the rate for a single session if you happen to be on top of the antenna with ideal circumstances. But of course, if it's a shared access and you're some distance from the antenna, or worse still, if you're indoors, then your service will be degraded quite rapidly. Now, there's a bit of opportunity to go across this thing, because that shows LTEs and HSPAs and Wi-Fi's, you know, so it just gives a sense as to why those things are interesting. But those realistic max rates are the realistic maximum rates in the access points, which are shared across the sets of users. And that just shows something of the potential for small cells. So one thing that you can do is you can move from a conventional macro cell, which there might be some tens of thousands, to street level clusters, which you might expect hundreds of thousands or high hundreds of thousands. Or indeed you could push it even further out to femtocells in homes, where you could end up with millions. So these are some of the things that are being considered at this point in time. And I think that was the point I made earlier, is that there's quite a lot of wireless access points already, which shows that something like 66% of broadband lines currently use Wi-Fi, because why wouldn't you? It makes sense. Bit of stuff about femto versus Wi-Fi. Probably don't want to get into too much detail on that, but in essence, I was at a conversation the other day there as part of a standards activity, where some of the mobile guys were saying, "Yep, well, Wi-Fi is the way to go if it's data that you're talking about." Femto proposition quite often is actually about voice in voice not spots for mobile coverage. So we've got a fixed world which we're enabling through NGA. We've got a wireless world which is being developed through mobile broadband, and we've got a role underpinning that, because our fibre circuits provide a substantial part of the backhaul for those mobile operators in the UK. What will all of that enable? A whole raft of applications, and if you're working in the software area for communications and distributed computing, then you'll be familiar with all those things. So network backup, HD TV content, video conferencing, interactive low latency, high-speed games download, whole raft of issues that need to happen in the infrastructure around this to manage things like rights for video content, enable monetization in the right way, deliver quality of service across the networks in the right way. But one of the things I saw quite interesting, it could be high-speed game download, or it could be a kind of interactive multiplayer games. In actual fact, a lot of the folks that are looking to now to deliver interactive multiplayer games, one thing that was kind of interesting for me was that when you talk to those guys, you realise that digital rights management is less of an issue, because the only way you can gain that experience in the interactive game, and because you're digital natives and I'm not a digital native, you probably understand this one better than I do anyway, the only way you can get that experience is by going onto that site and interacting with other people there. So rights management is less of an issue. The only place you can get the experience is with those gaming sites. I mentioned smartphones best connected via home Wi-Fi. TV-based video calling, thin clients, a big move towards cloud computing. That will happen in our generation. You think about how far we've gone since broadband was launched in UK in 2001, thereabouts. The fact that broadband has become an intrinsic part of all of our lives. I cannot begin to conceive of the things that we will see in 20 years' time. You guys might have some insights to that, but I don't. But certainly those are all the things that go on. So HD stream games, 3D TV, small premium over existing HD, maybe 20% with the stereoscopic type ways in those things work. Touchscreen telepresence, all manner. If you've been virtual, I don't know if you've seen some of the telepresence type systems where they've got those things set up like the other side of the table in a meeting room, and it's like you're interacting with people in the same room, apart from the eye contact. You haven't managed to get that one work. But if you can get eye contact to work, that would be good. So the journey so far in telecoms, all that manual stuff which drove the investment of our copper loops, digital switched, circuit emulation of these original operator connected calls, early dial-up access to computer hosts, then exchange delivered broadband, but the next generation that we're working on, next generation access to enable the full range of service types, fixed and mobile. So that really is a generational change. Hopefully I've convinced you that fixed and mobile will be absolutely complementary, highest bandwidth densities, where you want to do your 3D, HD video streaming, need best delivered on fixed with a short wireless access at the edge. And if you want stuff on the move, then that's where the mobile networks work. Applications have to be framed in an access agnostic way. You can see that we've created an Ethernet proposition which should enable some of that for the industry players. Terminal devices always best connected, and they'll get smarter about the way in which they do that. So they'll help you to find the best network and make that access very transparent. And applications on the network will be much more media rich, content aware. So if you're interested in some of the things that are happening in content aware networks with Van Jacobson and so on in the internet space, and that's probably somewhere to look. They'll be much more interactive, they'll be much more pervasive, and they'll be always available to you. So I've given you a flavour of what we're doing, and a little bit of the history. Hasn't been too interactive, but I'm hoping it's going to be interactive now. So thank you very much for listening.